Hi everyone, today we're talking about solving absolute value inequalities. This differs from solving equations by one little piece. We either have a greater than, could also be a greater than or equal to, or we have a less than or a less than or equal to symbol. And so this changes things just a little bit. First of all, in order to have two solutions, just like we did previously with equations, our C value has to be greater than 0. That's the same. Here's the part that changes. When you break it into two pieces, we have our positive piece that has the same symbol that we have in our original inequality, and we have the negative piece which now has the opposite symbol. Notice that we went from a greater than to a less than symbol when we switched to a negative C. And that's because when you divide or multiply by a negative number, you have to flip the inequality around in order to maintain a true statement. So again, this is changed from a greater than to a less than symbol. We could also have the opposite thing. We could be starting with a less than symbol, and in that case, our positive case is less than C, and our negative case is greater than negative C. Again, when you multiply or divide by a negative, you must flip the inequality around in order to maintain a true statement. So let's kind of break this down and take a look at what it looks like compared to what we were doing last time. So recall that we used isolate, separate, solve, ISS for short, in order to solve our absolute value equation. Doing that, we would take this simple absolute value equation of absolute value of x is equal to 2, and we would break it into two pieces. We either have x equal to 2 or x equal to negative 2. And we could plot those points on a number line. It would just be two dots, one here and one here. And so x is either right here or it's right here. Now, when we switch to doing a less than or greater than, then we are going to, again, use the steps from above. This is considered to be an AND case, and I'll talk about that a little more in a minute. So how it breaks down is that x is less than 2 and x is greater than negative 2. So when you plot this, here's what you're going to see. I have x less than 2. So if I plot that, I'm going to have a dot here, and I'm going to be headed in this direction. But when I plot x is greater than negative 2, I have a dot here, and I'm headed in this direction. So notice that my arrows overlap. So basically, we have one straight line between those 2 points, and x is somewhere in between. So we call this the between case. This particular case, instead of writing it as two separate inequalities, can be rewritten because, as you notice, x is in between two numbers. So we can just say that negative 2 is less than x is less than 2. So we can rewrite it that way. Here is our other case, and we call this the OR case. And you'll see why here in just a second. Whenever we split it into two pieces, we're going to have that x is greater than 2 or x is less than negative 2. So when we go to plot this, we have an open dot here with a arrow going this direction because we need to be greater than 2, but the other inequality, x is less than negative 2, goes in the opposite direction. So those arrows and those lines are not going to cross. So we call this the outside or opposite condition. So x is either over here or it's over here. It's going in opposite directions. I do want to remind you of our little drawing that we've been using to remember which symbols go with which dots. We have our less than or equal to and infinities go with an open dot and parentheses if we were going to be writing interval notation. And our greater than, equal to, less than or equal to gets a closed dot and a bracket. I have a mnemonic to share with you to help you remember that the less than symbol goes with and the greater than symbol goes with or. And that mnemonic is LAGO, L-A-G-O. It stands for less than, and then greater than is or, LAGO, L-A-G-O. This little graphic here is included in your Pear Deck, but I wanted to put it here too. This is kind of a summary of what we're looking at. So for a greater than symbol and a greater than or equal to symbol, that's going to be an or case. So we have ax plus b greater than c, or ax plus b is less than negative c. And then similar thing with the or equal to case. And again, reminding you that that or case has arrows pointing in opposite directions, either with closed dots or open dots, depending on if you have the or equal to part. Then we have our less than cases, less than or equal to. Remember, those are an and condition. And so we have an intersecting case or a between case where x is in between the two numbers.